I already log in. Okay, can you in the Microsoft team? Hello. Can you hear my voice in that? Okay, my voice is already back, right? After I fix about the is the result okay? It came from that I don't know that okay about this webcam. It's already have the microphone, okay? The driver of this device will be conflict from my computer, okay? The window is don't know what about the speaker should be, okay? The microphone should be, okay? Okay. I think everyone already take this. Try to finish the homework or assignment, right? It's about how to prove that, okay, event add with the event, okay, the result should be event or something like that, okay? After you do them, okay, wait a minute. Okay, finish all? Show me. Is it finished? Don't worry about that, okay? You may be right or wrong. I will give you the complete detail, okay? In this one, okay? In order to see that, okay, you try to do that first, okay? When you try to do that, okay, the thing you get, even though it's wrong, you may have the question, if it's wrong, okay? I think when you try to write anything in your answer, you already got proof from your understanding, right? And you decide that it should be right. Even though you don't know it's really correct or wrong, okay? It's good one, okay? Now, after you conclude that, the thing that you believe, okay, we will check that, the thing that you believe, how to prove them, and the truth, the fact that it's matching up. If it matches, it means your understanding is okay. But if it not, it means some part you might feel. Yeah? Next, okay. พรุ่งนี้เหรอพรุ่งนี้ไม่ได้เดี๋ยวพรุ่งนี้นะครับเอาเมฆป่ะหรือว่าถามเรื่องเราต่อไปเนี่ย You yourself or ask your friend a little bit? It's okay, don't worry about that, okay? อ๋อถ้าออกก่อนก็ต้องถามเพื่อนนิดนึงนะคือเข้าใจว่าแบบบางทีมันต้องพามันต้องเอาไปอีกใช่ไหมไปอีกของสิบนาทีไม่เป็นไรเพราะบางทีมันมีอาศัยในนิดเดียวถามเพื่อนนิดนึงไม่งั้นมันจะไม่ทันนะเพราะว่าที่จะวิชาที่มันถึงเวิร์กช็อปมันต้องเสียเวลาทำนิดนึงอยู่ไหนI would like to ask you one thing, okay? One question. Do you want to see the solution, or do you want to be think by yourself? If you would like to get the solution, raise your hand. Okay, so be it. Okay, I already have the solution. Okay, a few quick when we give it to you. Okay, and the more important thing is, the more important thing is the explanation from me. Okay. Okay. I will give you all. Okay. If, you can see that if I don't intend to give you solutions, why I create in the PowerPoint, right? Therefore, the first objective is to show you already. Okay. But I would force you to do it first. Okay. Okay. The way to prove that. Yeah. Okay. When we like to, okay. Yeah. We would like to prove that. Okay. The first step. Head. Okay. In this case, it's asked you to prove the sum of the two even function is even. Which means if the even function add with the even function, the result will be even, right? Okay? Yeah. If we define that x1 and x2 to be the even function, okay? Then, okay, x1 plus x2, okay? Y equal to x1 plus x2. Then you want to prove that y will be, okay? Now you will check that, okay, if y is an even, okay? Okay? Y, x1 plus x2. If x1 and x2 is even, right? You must prove that y will be even. Okay? How to show that the y is an even function? You know that the even functions yt is even when yt equal to yt minus 1. Y minus t, right? Sorry, y minus t. Okay? Yeah. Right? Now we write here y minus t, right? Okay? And the original definition is yt equal to x1 plus x2, right? x1 plus x2. Okay? If you minus it here, you minus it every term. Okay? In expression. Okay, now, right? We try to check that. Now, after you substitute that, okay, what about this equation? You try to read this equation, read the equations, okay? Yt will be y minus t will be equal to here. Okay, equal to here. Now we check that x1, x minus t. In this case, x1 is even or not? Even, right? Even. x1 is even. x1 minus t will be equal to x1t, right? x2 minus t is even or not? Even, right? You must know it's even first, right? Therefore, if it's even, you can prove that it's even. You can summarize that x2 minus t equal to x2, right? Yes. Yeah. From the definitions, you know that x1 t equal to x1 minus t, right? It's even. x2 t equal to x2 minus 3, right? It's even too. Okay. Now you substitute them in this equation. Okay. Substitute them in the above equation. Okay. Okay. You get here, right? You get here. Now you can see that. You can see that if it equal to x1t, x2t, x1t, x2t, it means x1t and x2t equal to yt, right? Now we can prove that, okay, yt minus 1 equal to yt, right? Okay, you can see that from the proof, you can see that if x1 and x2 is an even function, if you add them, okay, the result will be y even function too. Okay? Okay, if you miss some point, you can mark that. Okay? If you don't worry about that, okay, I think this slide is already in the Microsoft Teams. You can use the capture screen or so on. Okay? If it's already record automatically. Okay. Now, give you more. Okay? We have so many proof. Okay? Okay, now, if sum of the two odd function is odd or not, okay? The same. You define that, okay? Yt equal to x1 plus x2, okay? But in this case, if x1 and x2 is the odd function, okay? It's odd function. Okay, what about the odd function? The odd function, you know that, okay? Yt equal to the odd function if it is minus y minus t, right? Minus y minus t. We try to prove this thing, okay? From here, we prove in the right hand, okay, to modify this thing to be equal to yt, okay? To be yt. Now, we analyze it, okay? If it's okay, is an odd function, right? Minus y minus t, minus y, okay? Minus t minus y, minus x in here. Okay, now, we check it first, okay? Okay. You know that xt, x1, and x2 will be odd. If it's odd, how to prove that? Okay? It means if x1 is odd, it equal to minus x1 minus t, right? And if sorry, this x, okay? Therefore, you can write it here, right? Yeah. X2 is the same, right? X2 equal to here, yeah? We distribute them here. Yeah, you may have the questions why here, y minus c, I try to substitute this y minus c here in this bracket, yeah? Distribute them better, yeah? You can distribute them at the beginning, the same result, okay? Now you substitute same in here. X minus 1 minus t, okay? Is here. Minus 1 minus t is here. Give you to be, okay? You can see that. Give you y, okay? After you summarize that, okay? x1 and x2 term into y term. We show you here. Therefore, if y t equal to minus y minus t, you can conclude that odd or even? Odd function. Odd function. Yeah? Now, if in this case, it's a little bit complicated, okay? If x1 is the even, x2 is the odd instead, okay? We try to prove that, what about the output is, okay? Therefore, in this case, the way to prove, okay, we prove two things. One, it is possible to modify this term to be here. If you can modify them, it means the signal will be the result of the summation is even, okay? Or if it will be here, you can summarize, okay? You can prove that the result will be odd, okay? Therefore, you set the proof to be even or not, or proof to be odd or not. Okay? If both of them is failed, it means the result cannot be proved that even or odd. Okay? The first step, okay, if it's even, okay, you check that, okay, x1 is even. If it's even, it's easy, okay, x1 t equal to x1 minus t, right? Even, yeah. But x2 is a little bit complicated. If it's odd, okay, x minus, okay, x2t equal to minus x2 minus t. Yeah. Now substitute step in the original equation, try to prove that. Yeah. Substitute step in here, and here, yeah. Try to prove that. Okay, you can see that when you get here, you can see that it's not, okay? Yt equal to y minus t, right? Okay? Minus all, distribute it all, and here you cannot, okay? x1 minus x2 is not right. It's not equal to the original one, okay? Therefore, you cannot conclude that the signal will be even. This step you cannot conclude only. You can summarize that, okay? You can conclude it. It's not guaranteed that the result is even. But it's not or not, you're not sure. You must prove it another step. Okay? Another step. Okay? The second proof, okay, we will prove that y, okay, y, t is odd or not, okay? The same, okay, the same. If it's odd, y minus yt is here, right? You distribute minus 1 in here, okay? Okay? Because y equal to x1 plus x2, okay? Now, you try to reorganize the right-hand side of the equation to be yt. Okay? If this term can be summarized to be yt, okay, can be summarized to be yt, you can conclude that the signal, the result of the adding is odd. Okay? Organize that. Okay, the first term is that you can apply the even property. Okay? x1 equal to x minus 1. x1 minus c. Okay? x2 is odd. Okay? Substitute them in the above equation. Yeah. And in this case, when you substitute them, you can see that, okay? In the final step, okay, you get here. Okay? You cannot make them into the form of x1 plus x2. If it equal to x1 plus x2, if it equal to x1 plus x2, it's mean, okay? x1 plus x2, you can conclude that, summarize that this term equal to y, right? But in this case, it's not. It have minus. Yeah, it have minus. If it have minus, okay, if something only one side or one scalar, amplitude scaling or so on is, okay, if the form is different from here, you cannot conclude that. Yeah, if not equal. If it's not equal, it means from the proof, yt is not the odd truth. Now, from both. You summarize from the both, okay? You know that the result cannot be concluded that it's an even or odd. Yeah. For the multiplication is the same, okay? For the multiplication is the same. Yeah. Yeah. X1, okay? Multiply that. Okay? Y, okay? If X is the even, X1 is the even, X2 is the even, Y is the even or not. Yeah? Okay? You will see that multiply, right? Okay, we try to prove that. Okay, X1 minus C, X2 minus C must be equal to 1. If you can summarize this term equal to Y, you can conclude that the sum of the both even, the product of the both even is an even. Okay, now, in this step, we go step by step. Okay, from the definitions, X1 and X2, okay, is even. For the even X1, T equal to X1 minus T, X2 T equal to X2 minus T2. Yeah. Now you substitute them in the above equation, in the right-hand side section. Okay. The right-hand side section, okay. This term to be here, this term to be here. Okay. You can see that. Now it's already equal to X1 from X2. Okay, sorry, X1 multiplied X2, right? X1 multiplied X2 equal to the definition, right? If equal to definition, it means this term equal to YT, right? If equal to YT, you can summarize that, okay, Y. For any function that YT equal to Y minus T, that function is even. Okay? Is even. Okay? Now from the proof, the product of the two even function is the even. Okay? Proof is, okay, it's not difficult, okay? Therefore, I show you, okay, and I will give you as a little bit exercise, okay? Now, next one, if in the more complicated case, okay, if X1 and X2 is the odd, if it's odd, okay, it states that, okay, the product of them is even instead, okay? You see that? It's odd, it's odd. When you multiply them, give you even, okay? Okay. Now we will check that. Okay. For the even functions. Okay. The even functions y minus t. Right. Okay. Y minus t in this equation. Okay. This will be minus. This will be minus. And we try to prove them. Y minus t for the even function. It must be equal to yt. Right. It must equal to yt. Okay. Now if it equal to yt, it means it must equal to x1t, x2t. Right. We try to prove that. Okay, in this step you cannot take x1t minus, okay, it equal to xt directly. No. Okay, you must use the even property and the odd property. Okay, the odd property of x1 and x2. Okay, from the odd property, if x1 and x2 is odd functions, okay, you can see that x1 equal to minus x1t or here, okay, x2 equal to here. You substitute them in the right hand side of the above equation. Right hand side of the above equation. Okay, substitute them. Okay, what happened? Okay, you see that? This two, okay, x1t, x2t, okay. After that, we can conclude that is equal to x1 and x2. Therefore, in this case, it's equal to yt equal to y t minus 1. Therefore, you can summarize that yt is even function. Yeah. Yeah, I show you each step. Okay. Okay. The last one. Okay. If it's even and the odd, the result is the odd instead. Okay. If it's even and the odd, okay. See that? If it's odd, yt is odd. If y minus t. Yeah. Okay. And you try to prove them minus y minus t must equal to yt, right? We try to organize this form to be yt. And here, for x1 and x2, you use x1 for the even property, you use x2 from the odd property instead. Okay? Substitute them, okay? Substitute x1 and for even function, and x2 is the odd instead. For the x1, it's an even, it's easy. For the odd, it's a little bit complicated here, okay? Now, okay? For here, okay, x1 and x2 is here from this equation, right? Substitute step, okay? Okay? X minus t, okay, is here, x minus t, for x1 is equal to xt. Yeah, x1 equal to x1. Yeah, for x2, okay, x2 minus 3, okay, x2 minus t, okay, yeah, equal to minus x2 is there. Okay, minus x2, right, that means here. Okay, substitute step, okay. You can see that when you substitute step, okay, minus and minus give you plus. Okay, after that, if it's x1 and x2, x1 and x2 is here, right? Therefore, the right hand side equal to y. You can include that the result is, okay, the other function, right? Yt equal to minus y minus t. Okay. Here by this line, okay, and you can see them back again. Okay. Okay, for the common signal in the engineering, we already passed, okay. And next step, okay, I already introduced you about the singularity function. Okay, the singularity function. Okay, the singularity function that we study in the engineering course, we have only two functions. It means the function that have no derivative at some point, or have the derivative equal to infinity at some point. Okay, the first step we call the unit step function. Okay, the unit step function we use here, UT, unit step function. Yeah. Some may use HT, depending on. Yeah. S is came from the maybe the mathematicians who create these functions, outside or something like that. Yeah. But for me, I use for the engineering, we don't concern about the name who create them. Okay, we use them. Okay, write this. Unit step, therefore we use U. Okay, so easy to remember about this function. UT. The definition of the UT is very easy. For time length 0, it equal to 0. Okay, if time negative is equal to 0, time positive is equal to 1. Không được when time equal to 0. If equal to 0, 1, 1.5. No, it never define. If it never define, it's mean. It's have no value. Okay. Therefore, it's yeah. But in the engineering, you can see that it's difficult to sketch the graph, right? Because two graphs in the same graph, right? Came from the same graph. Therefore, in order to make it easy to understand, we make them, okay, connected together. Okay? Even though the riser, okay, although the riser is not strictly at a part of the definition of the unit step, but it usually show in each drawing to show that this thing is same function. Yeah. If you don't stop step yet, you see, you maybe have a wrong interpretation that this class and this class maybe came from the different function. No, it's the same function. Yeah, unit step function. Yeah, and in order to make this unit step function more general, in general, the discontinuity of the switch action is often take place at any instant that defined by T naught. In this case, what will it transform? Time shifting, right? Time shifting, okay? Time shifting in this case, if T naught equal to 2, okay, T naught equal to 2, T minus 2, you shift in the left hand or the right hand? Right hand by 2, this here. For example. Yeah? Okay, what about the unit step functions? Why it's very important in the engineering application? If you remember in the circuit, okay, when you turn on or turn off the switch, okay, turn on the switch, it means, okay, the switch is have no power, okay, voltage source don't have the power yet, okay, when you turn on them, okay, you have the voltage immediately at that point, okay, okay, some behavior of the circuit will be respond at that time, okay, for example, when you turn on the, maybe you go home, okay, at the evening, you turn on a lot of condominium house, okay, turn on the air condition. What happened? The lighting is flipping, right? Okay, came from RLC behavior. Okay, it's oscillating. Okay, the same. This came from the unit step. Okay, unit step function. And the second one is okay. The unit step, even though it's a symbol, but we can use them to model a more complicated signal. Okay, some very useful of the complex functions may be obtained by manipulating the unit step function, such as, let us define the rectangular functions will be defined by the unit step first. Okay, what about the rectangular? The rectangular, you can see that the rectangular simplify that, okay, is 0, okay, from an infinity to some certain point, okay, and 0 raised, okay, at the middle, it equal to 1. Okay, it's simply you turn on and you turn off, okay, the switch, okay. Now, how to write them or express them in the unit step form? You can write them in the two unit step function, okay, use the subtractions, okay. In this case, if T0 equal to 2, okay, if T0 equal to 2, okay, T0 equal to 2, T1 equal to 3, okay. The first one is here, right? Unit step is here, right? Yeah. Unit step shift in the right hand, right? Shift by 2. Okay, shift by 2. The second one is here, okay, if T1 equal to 1, 3, okay, it's the same. 3, yes. Yeah. This function, right? Yeah. In this case, 4, maybe use 4. Okay. If T1 set to be 4. Yeah. Yeah. And it's have. What about this transform? Time or amplitude? Amplitude. Reversal, right? With respect to vertical or horizontal? Horizontal, right? It should be here, right? You flip them. You get here, right? Now you add between them. The way to add the cloud, I already teach you, right? You add each of them. The first bit is here, 0, 0, 0, 0, okay? Okay? You add the cloud, okay? To be here. Now, okay? Okay? The orange, okay, we use the red for them, okay? Okay? The orange equal to 0. The orange equal to 0, okay? The pink equal to 0, 0, right? And then give you 0, 0, okay? Okay? Now, for here, yeah? Okay? The orange equal to 0. This point equal to 0. Okay? The pink equal to 1. 1. Yes, okay. 0, 0. Yeah? Yeah? This pink equal to 1. And then give you 1, 1. The result is here, right? Right? Okay? The rest is here, okay? Now, the orange, this point equal to -1, right? This point equal to -1, okay? The pink equal to 1. The pink equal to 1. And then give you 0, 0, give you 0, 0. 0 and 0, right? Okay? Clear? Okay, use the additional technique that I give it to you, okay? Use the graph and this technique, okay? Therefore, in this case, after you know them a little bit here, I will show you in the slide that more beautiful than blackboard, okay? But the blackboard will give you full detail of the computation. Okay, yeah. The first one is here, the second one is here, and the last one is here, the rectangle. Okay, the rectangle function. Okay. Now you may have the questions why unit step, the rectangle, frequently used in the engineering application. Therefore, when you study about the Fourier series and the Fourier transform in EMAP, you frequently determine the Fourier of the rectangle, right? Unit step also. Okay. In the future, it's have more complicated than this. Okay. Depend on this structure. Okay. This structure perform at the basis. For example, okay, it's maybe a several unit step or something like that. Okay, or maybe combine between the unit step and the ramp functions that came from, okay, straight line and with the unit step. For example, here, you see that, right? 0 and everything. Oh, sorry, maybe, sorry, multiply. 0 multiply anything give you 0, right? 0. Yeah. Okay, for here, 1 multiply anything give you that thing, right? For example. Yeah, you can use this basic structure to create a more complicated signal. Yeah, after we can write them, get the complicated signal into the mathematical form, you can apply Fourier series, Fourier transform. Yeah. Okay. Use them to instead. Okay, the way to multiply is already shown you in the book too. Okay, I can script that. Okay, because it's the same method. You know how to add them. Okay, multiply them. Now, this is application of the unit step. The next one is another one very important. Singularity function is the impulse function. Okay, the both function is that in the real world it cannot exist exactly. Okay, you cannot change the value of the voltage to be another one immediately. Okay, you can change them in maybe increasing in a very short time, but not suddenly. Okay, the impulse function. The impulse function is okay on the direct data function. The cosine mathematics definition of the unit impulse function or the direct data function is the data axis, yeah, right in there. 0 everywhere, except at time equal to 0. In fact, it's not infinity the length. It seems to be unbound. In the definition, it said unbound. What about the unbound? Unbound is very high, but it's not infinity yet. Very basic, okay? But for the engineering, we use that, okay? Not less to fully understand about it, okay? Okay, the amplitude of the impulse function is t equal to 0 is unbound in the precise. Okay, if you would like to know about that, you must study in the pure math school instead. And the mathematician who create this impulse function is already studied at the Bristol University, UK. Yeah, if you're interested about them, you can study at that school. Maybe the 6th or the 7th rank in the UK. You may think, oh, it's too difficult for you. No. Even though you go to the school and you maybe not study in the mathematics field, you may be in the engineering, okay? In the engineering school is maybe the rank 6 or 7. Okay, I know about that because, okay, my wife is already one of your senior. What about you here? Yeah. 20, 30? 30, right? 30 already? For you? What about your class? Kia thoát là 29? Yeah, it's me. My wife is X-Men the first class. Tier 1. Don't tell me about his how old. Okay. Yeah. He finished, okay, he graduated in the ABAC school, Tier 1, first class. He just have a chance to study in Bristol. Yeah. Therefore, he told that, okay, when I read the book, okay, hey, it's a function created from the mathematician from Bristol. Hey, you know about that? No, don't know anything. Yeah. It's very famous. You don't know anything. And what about your privilege? Don't say. What are you doing when you go to study PhD and master? No, not do anything. Really. Where's the time? From my point of view, you have a chance to go abroad, but she is very okay. She is not okay. Go anywhere. He only study, go home, study, go home, study, go home. Okay. It's different from me. Okay. For me, I try to use my life as much as possible. Okay, until I have the family I start. Okay. Okay, study. Yes, at the end, okay, drinking, okay, have the party, or so on. Okay, play the game. Even though game I can play is okay. Don't worry about that. Okay, I used to play with the professional league in the history. Okay, in Thailand. Okay, the Dota 1, the Star Club I used to play before. Okay, but now okay, it's I already own. Okay, it's already it's not my era. Okay. Okay, now we came back in here. It's about the history of the impulse function. The impulse is very basic. Okay, you see that zero everywhere and infinity at that point, and the property of that is so impressive. Okay, now for here, okay, if the impulse okay is here, if you achieve that, although the unit impulse function is not really exist in the nature, it has some mathematical okay. Many mathematical analysis and the application in engineering. Every transform developed from impulse idea. Laplace transform, Fourier transform, set transform. Okay, and moreover, the way to convert the analogs to be the digital world, use this function to use in the mathematics model, okay, to separate. But unfortunately, that this function is never exist in the real world. We try to make them as much as possible. Okay, it means we create the rectangle that have a very, very small one. Okay. Now in here, what will we transform? Shifting, right? If we shift by 2, okay, if t not equal to 2, shift in the left hand or right hand? Right hand by? See that? Okay. That's why I teach you about the signal transform first. You can see that when you understand about the time transform and the amplitude transform, when you treat about the signal, it's more easy to understand. Okay, it's only shifting. Yeah, it can. Okay, you can use. Okay, you can expand the original signal into so many different manners. Okay, now. Okay, from the practical point of view, the unit impulse function is traditionally used in the modeling sampling operation that used to convert the analog to the digital signal. Okay, because the result of the sampling operation is the selection of the value of the functions at a particular instant of time. Okay, and the sampling operation based on the unit impulse function. In fact, in engineering we use that. Okay, this idea, but in the real world, any function that the engineering can create to sampling the signal, right there? No, we try to make them as close as, right? As similarly as. Okay. Therefore, it represents that the mathematics that we simplify, that we model that, okay, is so precise. Okay. In the practical, it's different. Okay, and the way that different, okay, it has some effect that you must study. Okay, for each case. Okay, the sampling operation based on the unit impulse function. Therefore, the sampling operation is the ideal operation. Yeah, because the unit sampling functions cannot exist in the real physical system. Yeah, right? I told you before. The more impressive of the impulse function is the property of them. Okay, zero everywhere. Okay, except the impulse. Okay. Yeah, or you may be shifting them. Okay, seem to be you sudden change. Okay, to anywhere. Therefore, in this case, okay, that's why we told them. Okay, the singularity function. You can find the slope of them. If time less than 0, the slope equal to 0. Right? Time greater than 0, the slope equal to time equal to 0. You see that? It's very weird. Okay. When time in the 0 minus, okay, share to be here, right? Implicit. Oh, unbound. Oh, we assume them to be 1, for example. 1. Delta y divided by delta x, right? 1 divided by 0 give you plus infinity, right? But when time is 0 plus, change from infinity to be 0, right? Therefore, it will be minus 1, for example, give you minus infinity instead. You see that? The slope of them give you infinity and minus infinity. Can you get the graph for infinity. Right? Don't worry about that. Okay? And due to have the relationship between the unit impulse and the data function. Okay? You can see that in the data function, you can see that in this case. This slope equal to 0, right? If you differentiate this step, 0, right? If you differentiate this step, it equal to 0, right? But the slope of them, delta y divided by delta x, give you infinity at this point, right? Yeah. You can see that when you differentiate the unit step, give you impulse. Or reverse that. Okay? If you integrate impulse, give you unit step. Yeah? Unit step. Okay? For right hand, it's only you shifting them by T naught. You see that? You not necessarily remember that. Okay? You shifting them, shift every T by T naught, by the time shifting property. Another one very weird is when you integrate whole graph, integrate the impulse function. When you integrate the graph, give you area under that graph, right? Okay. For example, if I integrate this graph, for example, 1, 1, 1, okay, 0, okay, you integrate them, it gives you 1, right? The area under this graph equal to 1, okay? You integrate here, give you 1. Don't ask me why. Okay, for this, okay, based on the mathematics definition, and the way to prove them is very difficult. Okay, it seems to me it's very high, but it's very narrow. When you multiply them, it gives you 1. Okay, integrate the data function, give you 1. Yeah. Another two property is about here. Okay, if you multiply with the function and you integrate them, give you here and here. Okay, another two function I will show you in the next exercise. Okay, how to use them. Okay, the next exercise. Okay. Yeah. Yeah. Okay. If ft is here, okay, it's asked you to integrate from an infinity to infinity ft and multiply with the data function. Okay. You can see that you must multiply ft and the data function first, right? After you multiply them completely, you integrate it. Okay? You integrate. Someone see, oh, it's impossible to integrate. No. Think step by step. Okay? You multiply them first. The way you multiply, if it's 0, 0 multiply anything give you 0, right? Because the impulse is 0 almost everywhere, right? Now, you skip it first. Okay, the first part is here. ft, the original one, right? Original one. Yeah? The impulse function, infinity at t equal to 0. Okay, infinity at t equal to 0. Yeah, right? Infinity or unbound seem to be unbound. Yeah. Okay, if you seem to be unbound, 0 multiply anything, give you 0, right? It seems to be this point seems to be unbound, right? Very high. Okay, unbound multiply 2, it seems 2 unbound. Okay, 2 unbound. Okay, if you multiply that, okay, 2 unbound is here. Okay, seem to be 2 unbound. Okay, if you have 2 unbound, you integrate them. You integrate in power. If you, okay, when you multiply that, seem to be 2 in power, right? Yeah. Okay, 2. You integrate them. Integrate in power. Give you integrate from an infinity to infinity. Sorry. Yes. From the property, you integrate them the whole range and substitute the range of them. Give you 1, right? 1. Okay. Give it 2. Give you 2, right? Yeah. Y is 2. Okay. Or you can use the property to substitute it. Okay. 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 Equal to ft and t equal to 0. Okay. T equal to 0. Okay. Now the next one. Okay. Ft in this case. Okay. T naught equal to what about this transform? Shifting. You shift. Okay. In this case, shift in the left hand or right hand? Right hand by 1. Okay, by 1. Okay. The power is still the same, right? Power is still the same. Okay. Multiply that, okay? In this case, 0 multiply anything give you 0. And this pi equal to 3 in power, right? You integrate in power, you integrate 3 in power, give you 3. Now, to make you more understand, I give you another 2 example. Okay? 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 In this case, ft is the same. Okay? But the power, what will it transform? Shifting, shift by left hand or right hand? Right hand by 1. Right? Okay? Right hand by 1. Okay? Okay? 0 multiply anything give you 0. Okay? And the power multiply with 1 give you power. And you integrate the power give you 1. When you see this, it's more easy to understand, right? Even though you cannot touch the impulse directly, okay? But you can use the property to compute the result from the impulse. Okay? Is here, okay? Ft, what will this stand for? Shifting, shift in, right hand by 1. Shift by 1, right hand, the same, right? By 1, and here, right hand by 1. When you integrate them, give you 2, right? Give you 2 in power, and you integrate in power, give you 1. Okay? Clear? Yeah, now, until now, you know a lot of things of the signals, right? Why you must study signal? Okay, we have the problem that if you already have the clock that you can measure from the oscilloscope or maybe any theoretical instrument, okay, you can measure them. Yeah, you would like to analyze that, right? You can capture them. Yeah, you would like to analyze them. You can push this thing into the integration, into the Fourier transform directly. No, you cannot put the classical form, right? You must write them into mathematics form, right? Xt equal to t square log t sine t, something like that, right? If you be in this form, you can push them in Fourier transform, Laplace transform, or the other mathematics analysis. Therefore, the objective of this course is, okay, the way to write the graph into mathematical equation and the way to write mathematics into the graph. For example, when you integrate the graph completely, okay, when you integrate the function completely, you have the ability to sketch what about the real graph is. Yeah? Or when you have the graph, is here, you can sketch them. Hey, this term is came from the exponential t sine t, something like that. Yeah? Now, unless every mathematics that you have is useless, right? The graph is already in the real world. When you see the graph in the real world, the human voice, you see that, right? Human voice, it's already show you sine t, cos t, et, something like that. No, right? It's only show you continuous graph, right? You must convert them. If you don't convert, no one in the world can convert it for you, right? It's your job. Okay? Now, okay? Therefore, we have 2 steps. 1, write the mathematics. 2, graph. Another one, write the graph to mathematics. Yeah? This step is easier. This step is more difficult. Yeah? Therefore, yes. Okay? Therefore, in this case, we start by the first step. If we have equation, we try to write them in the graph first. Yeah? How to write them? Very easy. A minute. Yeah? I will show you in the example. Yeah? You already have the function in here. Yeah? Cut them. split the mathematics, the whole mathematics equation into a simple form, a simple term. How to split them? You split them by add or the subtraction operator. Yeah? Add or the subtraction, not multiplication and division. Clear? Now in this case, add and subtraction, add and subtraction. How many terms we can split? How many terms? 4 terms, right? 4 terms. Clear? Yeah. Is it difficult? Everyone know adding and the subtraction, right? Because you study since grade 1. Yeah? Adding and subtraction. Yeah. Now, after that, you analyze each term. You term first, okay? Scan each term. T, U, T. Yeah. For U, T, you know that in the previous step, right? U, T. Okay, it's out. Yeah, right? UT, what about UT? Okay, 3 UT. Okay, what about this one? Amplitude, scaling, right? UT, you can scale it, right? What about UT? How many times 0 is equal to? 0. How many times 0 is equal to? Right? Scale by? Amplify or expand or compress? Expand, right? Expand by 3 times. 0 multiplied anything give you 0, right? Okay? Okay? You can write the first piece of this graph. Okay? Okay? Now, next step, okay, next step. Okay? The second term is here. T, U, T, right? T, U, T. Okay? Now, it came from T and the UT multiplied, right? UT, you can scale them. Half greater than 0 is equal to? Half greater than 0 is equal to? 1. Yes, right? And, okay? Y, okay? X equal to T. What about this? Rising graph, right? Rising graph. The slope equal to 1. Slope equal to 1, right? Yeah? Yeah, now. 0 multiply anything give you 0. Yeah? 1 multiply anything give you that thing, right? Give you that. Clear? You see that? After you split them into a simple term, it's possible to write it, right? Now, finish? No. Another one is here. Right? This thing is shaped by the same manner, right? Therefore, this term is came from right? You shift them in the center. And you will use the what are the transform? Shifting shift by 1. Okay, now TUT, you already scaled in the previous one, right? Yeah, and here, right? But in this case, we have minus in here. Minus is represent for half or amplitude. Amplitude reversal. Flip respect to vertical or horizontal? Yeah, right? So yeah, shifting them, okay, shifting them, don't worry about that, okay? You're shifting them by 1, right? Shifting the left hand or right hand? Right hand by 1. Okay, the pink one, keep it here. Clear? Okay, in the book, okay, in the sheet, it's already show you each step, but maybe don't show you in the detail where it came from the lecture. But I think you can trust that, okay, after you listen about the lecture. Yeah? Finish? Finish? No, we have another one term, right? Minus 5 U T minus 2, right? UT, you can see that the top of them is UT, right? Time greater than 0, 0 time greater than 0 is equal to 1 represent for reversal. 5 represent for amplitude scaling. -2 represent for which step we take first? Time first or amplitude first? Amplitude first. For the amplitude, which step we take first? We take scaling, right? If we have scaling, we amplify the signal by 5, right? Yeah. And next step you take reversal. Quick respect to vertical or horizontal? Horizontal. Horizontal, right? Yeah. Right. This class. Yeah. Next step you shift, right? Shift in the left hand or right hand? Right hand by 2. Yeah. Shift in the right hand by 2. Therefore, the class will be here. Okay, right? The blue one. Okay. I think in the slide is trying to show you. Now, finish? No. We have another main trace at it. Okay. I think it's okay. That's why I must teach about the signal transform and try to confirm about that. You can see that in this case, we use them. If you not fully understand them, you miss one of them, the final result is wrong. Okay, now. Okay. We try to find that how many and how many colors we have. Okay, almost all. Okay, okay, you can see that when you adding them. Okay, I already told you that. Okay, you cut them into each piece, right? How to cut them? Okay, yeah. When some class it change the value or change the slope. Okay, cut them. Okay, yeah, you can see that this step is the blue is straight line. You have no problem, right? The pink is straight line. Oh, sorry, the orange is straight line. Okay, the green is straight line. You have no problem, right? But the pink is not, right? The pink is have change the slope. Okay, therefore cut them. Okay, yeah, you can see that for F2. Okay, at time equal to 2. Okay. 3 of them is still the same, okay? Only blue change the value suddenly. Okay? Okay? Okay, for here, 0. Okay, you know that is 0, it's easy. Okay? You want to know about that. Okay? Now, analyze them first, the same. The blue equal to 0, 0. Okay? Okay? The pink equal to 0 and 0. Okay, yeah. The orange don't have the orange. Okay, the orange is equal to 0 and and the green equal to 3 and 3. You adding them, give you 3 and 4. Yeah. Next step. Yeah. Okay. The blue equal to 0 and equal to 0. Okay. Yeah. The pink equal to 0 and -1. Okay. Okay. The orange equal to 1 and 2. So 1 and 2. Okay. The green equal to 3 and 3. Okay. Adding them 1 and 3 give you 4. -1, 2, and 3 give you 4. Right? 4 and 4. Yeah. Now for this, in fact, in infinity, it's difficult to sketch, but you know that the cloud will have the same slope and same direction. Therefore, you must cut them to be only 1 or 2 points. Okay? Okay? The blue equal to -5 and -5. Okay? The pink equal to -1 and -2. Okay. The orange equal to 2 and 3. 2 and 3. Okay. The green equal to 3 and 3. Yeah. Adding them, -5, -1, 2 and 3 give you -y, -1 give you -1, right? Yeah, -1, -2, 3 and 3 give you right? -1 and -1 should be here and here, right? Okay, at the cloud we have the same slope, right? From them, in between them is 0, right? Okay, I show you in the okay, show you the detail how to compute them in the blackboard, give you more understanding. Okay, now, okay, I will show you in the slide, okay, to fulfill. Okay. So read them, okay? The first piece is here. Okay. The second piece. The first piece, right? And the last piece equal to -1 and -1, right? Where it came from. You can see that from the mathematics, you can sketch the cloud. And yeah, in the future, the cloud you have the ability to sketch in the mathematics too. Okay? Okay. Okay, the way to write, okay, the mathematics to be cloud. Okay. Write the cloud to the mathematics, okay? If we have this cloud, how to write them in the mathematics form? The way to write the cloud in the mathematics is more difficult than the previous step. Yeah. The way to compute that is not difficult. The same as the previous. If you have the mathematical equation, you split them by which operator? You split them? Addition or subtraction? Yes. Okay. From the cloud, you must split them first. Okay. But the cloud it have no addition or the subtraction clearly, right? How do you add them? Okay. You check first. If the cloud check. Okay, if it's straight line, you have no, okay, no checking anything, it did, okay, but if we change the slope or change the value suddenly, require one magnetic circle, okay, now, yeah, the slope equal to 0, right, the slope equal to, delta y divided by delta x equal to, delta y equal to 3, delta x equal to don't know how to compute the slope. You can use 2 points, right? Right? Yeah? It's here equal to 1. Yeah? Okay, if it's negative, okay, if you use them, it's left right, you use x and y. But if you use here is left right, you use them to be the left right for x and y both. Yeah? Okay? The slope equal to 3. The slope equal to 0. You change the slope, right? If you change the slope, it means one mathematical term is required. Okay? One mathematical term is required. Okay? It's fine. One mathematical term. Okay? Yeah, the slope equal to 3, right? The slope equal to 3. This slope equal to minus 3, right? I don't have a time to teach you how to determine the slope of the cloud. Okay? Yeah? I think everyone has ability to find. Okay? Ability to determine the slope of the cloud in a study maybe class 7 or maybe of class 8 and more. Right? Okay. Change the slope. Another one term is required, right? Yeah? Change the slope or not? No. Change the slope or not? No, right? It's straight line. Change the slope or not? Another one term is required, right? This slope equal to 0. This slope equal to 0. Okay? Change the slope or not? No. No slope, right? The slope is 0. The slope is 0, right? But it changed the value suddenly. Yeah? It's required another one term. How many mathematical terms you require? 4 terms. 4 terms. Clear? You split them by, observe that, okay, how many the slope is changing or it changed the value suddenly. Yeah? After, you know that, you require 4 terms. Go to the next step. The next step, okay, you cut them first, okay? This thing is required the first term, right? Require the first term, okay? What about this cloud? Okay? This cloud is here, right? Right here. Yeah, that's 2. Sorry. Minus 1. Okay. Yeah. If the cloud is in this shape, right? You know that in the previous you may use T, UT as the basic, right? Yeah? T, UT is here, T is here. You know that the result is about that. Okay? T, UT. But you must use the signal transform to make them match to the thing that you would like to model, right? In this case, the first step, the slope of TUT is 1, right? This slope equal to this slope equal to 3, right? The slope equal to 3, therefore it should be at 3. Right? 3. And the second one, TUT, okay? It's changing the value at T equal to 0, right? At T equal to 0, but this value change the value at T equal to minus 2, which transform we require? Time shifting, right? Time shifting that we require. Shifting the left hand or right hand? Right. Right. Yeah, in the left hand form. Yeah. Therefore, in this case, T plus or minus 2. U T plus or minus? Yeah. And you can get this cloud. I think I show you this step, you will more understand. But when I give you exercise, don't forget to do it, okay? Because I think this time for this lecture is not enough to do in the class, okay? Okay? Now, can I rest? Okay? The first cloud is here. See that? The first cloud is here, right? The first that we model is here, right? 3 T plus 2, UT plus 2, right? Already matched, okay? Now, the next step, okay? You try to model this cloud, right? This stuff based on the previous one. Okay, we added it. Okay. Now in this step is a little bit complicated in this manner. The slope for this step equal to 3, right? The slope for this equal to minus 3, right? Okay. We just say if it's okay, if it's straight line, maybe have the okay not unit step function you use okay UT TUT. at the basis. Okay, but in this case, you cannot use the slope -3. No. -3. Yeah, the new slope not only make the new graph equal to -c, but it might cancel the previous effect, right? Cancel the previous effect. Okay, therefore the slope will be equal to the current slope. Subtract with the previous slope. The previous slope equal to -3. Yeah. Yeah. Therefore equal to -6. Yeah. And this here, okay, is changing the slope at the point equal to -1. What about the transform we require? Shifting. In this case, you shift in the left hand or right hand? Left hand. This term will be changed to be t plus 1 u t plus 1. This, yeah. That's 1 -6 t plus 1 u t plus 1. Yeah. Now, okay. Next step. This slope is -1. This slope equal to 0, right? 0. Okay. The same. We require t ut star. Okay. The slope of them equal to 0. Okay. 0 minus with -3. Only here. Only the current slope, not this part. Okay. The apparent. Okay. The apparent. Okay. And TUT this here. The graph change the slope at time equal to 1 second. Okay. 1 second. You shift in the left hand or right hand? Right hand. Therefore, in this case, t minus 1 u minus 1. Okay. Give you 3 or minus 3? 3. Yeah. This 1, 3. Okay. In the slide, in the sheet, it's already give you final result, but don't tell you where it came from, right? But here, it will be combined with directions, okay, to state that where it came from, to give you fully understand. But even though you understand, you not really understand until you really do. Yeah. Last one, okay? Last one. Can I erase this? Yeah. Yeah. The last one is here. Yeah. Yeah. The slope equal to 0, right? If the slope is unchanged, you not necessarily to use u t. No. Yeah. It change the value only, right? Change the value suddenly. ut only enough. Yeah, ut. In this case, it change up or down? Up by 3, right? Up by 3. You only add with t. But the value it change at time equal to 3. Shift in the left hand or right hand? Right hand. Therefore, this term change to be u t plus or minus? Yeah. อันไหนเอ่ยสโลปเปลี่ยนไหมไม่เปลี่ยนเหรอนี่สโลปเท่าไหร่ไม่เกี่ยวเอาสโลปที่เปลี่ยนนี่สโลปเท่าไหร่ เท่าไหร่สโลปแกนพุ่งลงเงี้ยแล้วก็3เรียนวิชาไหนมาถ้าลบ3สโลปลบ3อันนี้สโลปเท่าไหร่0สโลปเปลี่ยนไหมจากลบ3เป็น0เปลี่ยนไหมสโลปถ้าสโลปเปลี่ยน if the slope is change which term we use TUT or UT TUT จบไหมbecause some of the time is up right, some of you must go before the ink will be kill you. Okay? Exercise. Help me to do it the next time. Let me give you the solution. Yeah. 18, 19, 20. 18, 19, 20. Okay, and next time I will give you a solution. Yeah, 18, 19, 20. ดีไหม89 20. Okay. อะไรไม่ไหวแล้วเป็นไรง่วงกินกาแฟสิไม่กินโค้กก็ได้ผมรู้ว่าเรื่องการสุขภาพเขาชอบกินโค้กกินกาแฟกินคาเฟอีนกันผมไม่เคยเปิดดูเลยตัวตลาดเพิ่งไปทำได้ดีเมื่อปีที่ผ่านมาเนี่ยไอ้ตัวเล็กกินโค้กตอนแบบ4 โมงเย็นเนี่ยไม่คือไม่นอนไม่กินเลยไปเลยนี่ไม่ใส่โค้กได้เลยเขามียินเวลาหลังไปโค้กห้ามกินโค้กเด็ดขาดไม่งั้นพ่อแม่จะไม่นอนalertจัดโอเค try to finish only 3 okay the other if you can finish is good okay but 3 is important I will show you in the slide okay about the solutionแม่อันนี้คือเหมือนว่าถ้าเขาให้อีกเวชั่นนะคุณเขียนกราฟได้ไหมเขาให้กราฟมาแล้วให้เป็นอีกเวชั่นแต่กราฟฟังก์ชันอะไรก็ได้ไม่สนเพราะว่าแบบที่บอกไปว่าถึงว่าจริงเนี่ยคุณอ่านค่าจากสังคมแล้วได้กราฟอย่างนี้มาเนี่ยคุณเอาค่าเนี่ยอินดิเคตได้ไหมเสร็จแล้วพอมีกราฟคุณต้องเปลี่ยนก่อนถูกไหมพอเปลี่ยนเป็นแบบปั๊บอ่ะคุณถึงอินดิเคตไปได้ถูกไหมหรืออันนี้ก็คือถ้ามีบางทีเราอินดิเคตไปแล้วเราเอาย่างของเราถ้ามันน่าทานดีกว่าคุณไม่พอดมันมีใครพอดคุณไหมไม่มีเราต้องพอดเองนึกออกไหมแล้ววัตถุประสงค์นี่คือแค่2 อย่างแค่พอดกราฟที่ไหนหรือเขียนแบบกราฟแล้วเดี๋ยวมันจะใช้ในอนาคตเพราะว่าอนาคตเสียต้องเรียนฟูเรียเนี่ยแต่ฟูเรียสมัยคุณเรียนมีแบบหรืออินดิเคตที่คุณเรียนกำลังจะรู้อาจารย์ให้เลยใช่ไหมวายเอ็นก็มาเอ็นกำลัง2แต่อันนี้ต้องไม่ให้เนี่ยถึงกินกราฟตัวเอ็นกำลัง2เขียนเองโอเคกำลัง2ก็ถามถ้าคุณเขียนไม่ผิดไม่ต้องพูดถึงอินดิเคตที่ใส่แค่2 หน้าเขียนตอนต้องจำเลยถูกไหมเดี๋ยวจำเลยแล้วนะถึงบอกว่าถ้าตอนแรกมันเหมือนมันง่ายประสบการณ์ที่สุดเลยเพราะว่าจะมาอาจารย์ดูอินดิเคตดูฟังก์ชันคุณผิดแล้วเหลืออะไรอะไรนี้นะเพราะฉะนั้นถึงต้องเสียเวลาทำไมผมถึงต้องโซลาร์นะเรื่องซิงกับการฟอร์มเรื่องอะไรเพราะว่าตรงนี้มันต้องแม่นต้องไม่แม่นนะนึกออกไหมผมสั่งสอนผู้เรียนไม่ว่าการผู้เรียนผิดแล้วที่คุณใส่เด็กผู้เรียน3 นะเหลือไม่เหลืออะไรเลยนึกออกไหมคือแบบว่าชีวิตตอนนี้ถึงบอกชีวิตตอนนี้เหมือนเกมโดต้าทูเลยเล่นเฟสสำคัญที่สุดคือต้องทำบุญมันดีนะโอกาสแพ้มันไม่มีเมฆทำแพ้แล้วใช่ไหมถ้าโอกาสแพ้หน่อยไล่ไงนี่ก็เหมือนกันถ้าทำต้นมันถูกหลังๆมันโอกาสผิดมันมีอะไรแต่ถ้าต้นมันผิดนี่นะเหมือนเราต้าเปิดเกมปั๊บมึงตาย ายคนละ10 แฟกเนี่ยโอ้โหผ่านไป15 นาทีเนี่ยกูอยากออกเรื่องอะไรกูอยากลีแล้วหรือเอาลีกูอยากลีนะกูอยู่ก็ออกไปลุยกับเขาก็เละไม่ออกไปลุยป้อมกูก็เละจะอยู่ตรงไหนดีจะลีเดี๋ยวก็โดนแบนใช่ไหมคือบางคนก็เบื่อกูอยู่แต่บอร์ดไม่ก็รีพอร์ตกูAFKอะไรเนี่ยคือนึกออกไหมช่วงนี้คือวิวางานคือวิชาวิวางมันจะเหมือนโดต้ามากว่าไม่มีวิธีทำแบบไม่มีปฏิหารหรอกคือเป็นทำทีละขั้นตอนนะทีแรกมันตั้งใจทำอ่ะมันไม่เกินวันแรกมันก็ออกอากาศก็พอนะเรามองแล้วข้อสอบมันก็เหมือนมีโลกฝั่งตรงข้ามเดี๋ยวมันมาที่เหมือนมาที่เฟิร์มแล้วผมอยากเปิดเป็นคนแล้วจบเรียนเสร็จค่าแล้วที่เฟิร์มมันมาแล้ว2 เดือนตั้งรับได้ไหมเรียนน้อยก็อย่าตายวะเรื่องผมที่ก่อนบอกไม่ตายโอเคนะเปิดที่เหนื่อยดูไม่ตายโอเคแล้วหรือตายแรกกันเราตาย3ก็อย่างดีว่าคุณไม่ได้ตัวคออะไรอย่างเงี้ยเหมือนกันก็คือต้องเข้าใจก่อนถึงเวลาก็ไปอยู่จริงผมไปอยู่จริงวิถีมันตรงมีวิธีคนหลอกที่แบบง่ายชนะสารไม่มีแล้วนะให้สูสีพอสูสีปั๊บไปฟังหมอดิเพื่อจะสู้ต่อสวัสดีครับมีอะไรกันเลยเอาให้ดูอ๋อทำไมอันนี้มันมีหลายรูปแบบค่ะที่ต้องเช็คมันมีหลายรูปแบบแล้วว่ามีที่ของอะไรมีลงถ้าเปิดจะตัดแต่ถ้าไม่รู้ก็ต้องเสียเงินมันไม่เพอร์เฟกต์ใช่ไหมแล้วเป็นดูยังไงมองไม่เห็นหรอกมันเหมือนกับยางอะไรก่อนด่านข้างในเลยบางทีมาก็มองต้องใช้มือครับต้องแบบเอาส่องแสงโอ้โหมึงส่องแสงตามลึกต้องการแต่มันจะมีป้ายเขียนอยู่ว่าชิ้นไหนมึงก็ทำใจเลยนะกล้องเนี่ยมันไม่ได้เป็นพระเจ้าถ้าตามลึกมันดีถึงไม่ได้กล้องไม่ก็ดีถึงไม่ได้คือลักษณะอย่างหนึ่งที่คุณต้องยอมรับว่าเราเรียนแบบธรรมชาติกล้องเราต้องเรียนแบบตามนุษย์แต่มันไม่ได้ดีเท่ากับตามนุษย์เพราะว่ามันดูดีกว่านะแต่ตามนุษย์เนี่ยใช้กลางคืนก็ได้ตอนคือสภาพไม่ตอบได้ปิดไฟแรกๆมองไม่เห็นเลยแต่ผ่านไปสัก10 นาทีตาเราขยายได้พอมองเห็นแล้วตาใช่ไหมหรือว่ากล้องเนี่ยมันมีเลนส์อยู่เกินนี้ก็ไม่ได้แล้วเพราะนั้นมันไม่มีทางได้หรอกเพราะว่าอย่างเขาอย่างพวกเฟซเรคคอร์ดิชั่นเนี่ยมึงใส่หน้ากากหรือว่ามึงหนักอีกนะครับบางทีมึงก็มองไม่เห็นเพื่อนถูกไหมถ้าใส่เฟซปั๊บใส่หน้ากากเรคคอร์ดิชั่นเด็กกระป๋องนี่ถึงได้เพราะฉะนั้นถ้าคนมันยังทักผิดขนาดมึงเปิดหน้ามึงเดินไกลๆมึงดีไม่ได้ใส่แว่นยังทักเลยเฮ้ยกูไม่ขันมาว่าขอโทษครับอะไรอย่างนี้ใช่ไหมคือมีนักอยู่เยอะแล้วเรคคอร์ดิชั่นไม่มีทาง100%หรอกนี่ก็เหมือนกันคือปัญหาที่มันคอมพลีเคทขนาดไหนน่าจะเป็นเสียรูปนี่คือหล่อมันไม่ดีได้หล่อไหมหรือไม่ครบใช่ไหมเสียรูปคือมันจะเบี้ยวโอ้โหเบี้ยวดูเป็นยาเลยนะเบี้ยวเดี๋ยวต้องนึกก่อนมาบอกตรงนี้ต้องขอนึกก่อนช่วงนี้ไม่เรียนสอนตลอดเลยได้แล้วไอ้คลิปติดชิ้นงานนี่เป็นไงวะใช่ครับแต่มันมีส่วนเกินอย่างเงี้ยเหรอใช่มีส่วนเกินได้ต้องขอเลยยาไม่เต็มที่อะไรยาไม่เต็มอะไรคือเบาหายไปมึงทำเหมือนโสดเป็นแท็กซี่มีบ้านกินอะไรตอนเก็บเห็นสร้างโดยแรกนะขอให้เราทำเป็นแผนสร้างอะไรนะเป็ดนอกเปื่อยพูดแล้วคุยอย่างที่เป็ดแม่ที่มันก็นอกเปื่อยเยี่ยมเลยเขียนกันว่ามากเลยเยี่ยมบอกว่าเขียนยาวเขียนเต็มแม่ก็เปื่อยเป็ดนอกเปื่อยไม่แดกอะไรเงี้ยเลยไม่รู้ครับมีโรคเท้าเปื่อยเลยโอ้ยรุ่นพี่เองเป็นคนเขียนตัวไทยMKรู้เปล่าMK ก่อนก็จะทำเรื่องงานบอกว่าจบใช่ไหมเขียนแล้วก็เขาใช้แผ่นโมเดลแผ่นเนี่ย จริงๆเขาทำโปรโตไทป์มาก่อนแล้วก็ใช้โมเดลเนี้ยเซตแล้วเขาค่อยไปตั้งบริษัททำแล้วเจ้าคณะบดีคนแรกก็คือพ่อแกซีกับเอเคก็ขอมาแล้วมาโปรเจกต์เขาก็เลยมาช่วยทำเลยว่ารุ่นพี่ผมเองอะเป็ดนอกเปิดเที่ยวเลยไปกินด้วยฉันก็ต้องเขียนเยอะมีที่เขียนเดียวแล้วแผ่สมัยก่อนไม่กับนิดนึงเนี่ยใจเขียนเต็มไม่ตกหน้าเขามองไม่ออกเลยว่าสั่งเป็ดอะไรกลายเป็นเป็ดตุ๋นเป็ดอะไรไม่รู้เข้าเนื้อชิ้นเนี่ยนี่คือไอ้เสียรูปมันมองยากเนี่ยเพราะว่าเวลายาเปลี่ยนมาหลอกมามันไม่เป๊ะอยู่แล้วคือถ้ามันเป็นลิจิสบอดี้มันยังได้แต่มันยาเนี่ยมันน่าจะยาวอีกหาไม่เจอเลยลูกอีกคนลูกของงานหาไม่เจอเลยของจะหาเจอไหมวะ
ต้องแบบถามที่ธนาคารที่เขาเชี่ยวชาญ
ได้เดี๋ยวพกกันให้ดีไว้ผมไม่อยากเอาไว้ที่ผมเดี๋ยวผมไปนั่งนึกก่อนเดี๋ยวต้องไปถามพวกที่เขาทำของพวกแฟคทอรี่ตรงว่าเขาใช้อะไรเดี๋ยวจะได้นึกได้ว่ามันทำยังไงคือต้องเข้าใจว่ามันไม่ได้เกี่ยวกับมันใช้อิมเมจเดียวเลยมันต้องดูว่าใช้อะไรที่มันเป็นที่สุดสำหรับงานประเภทนี้นึกออกไหมถ้าใช้อิมเมจได้ใช้แต่ใช้ไม่ได้เนี่ยมันจะใช้อย่างอื่นไหมแน่นอนว่ามันใช้คนเนี่ยในเออร์เลอร์ก็ไม่เวิร์กเลยยาวไม่งั้นซีพีโรงงานมันค่ามันไม่ได้กำหนดในโรงงานไม่กำหนดใช่ไหมเพราะว่ามันมีปัญหาเรื่องความสะอาดมันมีปัญหาเรื่องระยะยาวผมมองเอาCE7มองว่าข้าวของทั้งหมดเนี่ยมันโรงงานมันไม่มีคนด้วยเพราะไอ้คนปั๊บให้เขาไม่มีหนูไม่มีเป็นสาเพราะไม่เก็บอาหารทุกเม็ดเลยทุกดอกคือการันตีว่าอร่อยหรือเปล่าไม่รู้เค็มไปหรือเปล่าไม่รู้ไม่สะอาดแดดไม่ของเสียแน่นอนนึกออกใช่ไหมนั่นคือสิ่งที่การันตีได้เพราะฉะนั้นนี่ก็เหมือนกันเดี๋ยวดูนะเรามาให้ดูเนี่ยมันจะนึกออกว่ามันมีดีเฟกต์ยังไงเดี๋ยวจะได้จินตนาการว่าจะต้องใช้อะไรมันไม่ช่วยกันทำมั้ย
ก็เป็นโปรเจกต์ครับโปร
เจกต์ทำเร็ววะ
เนี่ยครับเป็นโปรเจกต์
ที่เนี่ยโปรเจกต์
ใช่ครับ
แต่โรงงานต้องไปถามเป็นเซอร์
ไม่มีเลยครับเขาจะนัดประชุมกันเลย
อ๋อจะเลือกเป็นเซอร์ใช่ไหมอ๋อที่เนี่ยโปรเจกต์หนึ่งป่ะใช่ไหมก็ต้องมีเนี่ยไม่ต้องบอกกูรู้มึงที่ไหนเอาละเดี๋ยวค่อยว่ากันนะเพราะว่าผมมันไม่ใช่หรอกคือผมมันมีข้อเสียอย่างหนึ่งคือผมเนี่ยไม่ค่อยลงไปดูแลรายละเอียดของงานของเด็กๆเพราะฉะนั้นเนี่ยจะปล่อยพวกคุณทำเองมีปัญหาก็วิ่งเข้ามาผมก็เลยอาจจะไม่ค่อยเหมาะเป๊ะกับพวกซีเนียร์